So dear students, here fifth practical is today. The fifth practical is basically the temperature sensor. We have to connect the temperature sensor to the Raspberry Pi, and we have to see the on the environment how the temperature change and detected by the Raspberry Pi, and it will be shown by the virtual terminal and the simulation log. Okay, so accordingly, the connections we have to start again with the new project. There is our practical number 5. The practical number 5. We have to verify the temperature sensors. So rename it with the temperature sensor. Okay. Again, the path is same for your roll number. I am saying in the IoT practicals in the Proteus. So I'm selecting the my folder which I have created during our practical sessions. So you have to create same folder with your roll number. Okay. So then select the folder, and after selecting the folder, the path, you have to see the clear path of your folder here visible. Okay. So after this, if you have to, whenever, just remember whenever you start your practical, rename your the practical with number and the name. Okay. Here we are performing the practical number 5th of the temperature sensor. So I have already renamed the practical number 5 with the temperature sensor. Okay. Then go to the next. After going to the next, again, the same procedure to create the semantic from the selected template, and it will select to the default. Then next, and here a selection by default, that is a do not create a PCB layout. Okay. You have to always remember there is two options. First one is the create the PCB layout from the selected template, and second one is the do not create the PCB layout. Okay. So always we are performing the practical on the semantic capture. So remember ki do not create PCB layout is selected. Okay. Then go to the next. Go after going to the next, again create a firmware project. We have to perform our practical on the Raspberry Pi. So after the selected the Raspberry Pi family, the controller is visible, the Raspberry Pi 3, and the compiler is the Proteus. Okay, then go to the next. And here the summary of the selection of the path and the components, of the controller and the family. So we have selected the firmware project into the Raspberry Pi 3 compiled by the Python Proteus. Okay, and auto place processes on the semitics. We have not selected all the PCB layout. We have created on the semantic capture. So whenever you start the practical, always see the summary of the selection of your folder and the PCB layout, no PCB layout, and the selection of semantic. Okay, that is important for the our practical. Then go to the finish. Okay, again, whenever you finish your semantic capture, there the two windows is open. First one the semantic capture, and second one is the same source code. So the by default source code is not for us, so delete it. Now the semantic capture of Raspberry Pi 3 is visible on your Windows. Okay. So now today we have to perform the practical number 5. The practical number 5 is our temperature sensors. We have to verify the temperature on the environment in the present, and how the our controller is directing and fetching that data and showing to us. Okay, here we are using the simulation log because of the virtual terminal. Already I am performing in the virtual terminal, but virtual terminal is not showing the proper outputs. So I am using the simulation log. I will show you how to use the simulation log for the output. Okay. The first component we required for the our practical, the temperature sensor. Okay. So temperature sensor, that is LM35. So go to the component mode, and go to the P and search here the LM35. LM35. So that is LM35. Okay, temperature sensor. The range of this temperature sensor is minus 56 degrees Celsius to the 150 degrees Celsius. Okay, on the simulator. So select it and activate. Okay, we know that the temperature sensor is basically work on the data of analog. Okay, the data work on the analog. So we require the tag. Basically, that will be convert our analog to the digital. Okay, we require the tag data. The tag data is basically the MSP3008. MSP3008 is your ADC converter that convert the analog to the digital. Okay. So go to the component one and again search the data, that is MSP 3008. Okay. MSP 3008, that data is your ADC converter, that is convert to the analog to the digital data. Okay. Select it and activate again. Okay. Where you have to activate accordingly. Okay. So here that is your MSP 3008. MSP 3008 is basically our the ADC converter that convert the analog to the digital. Okay. We have now the our LM35 is working on the analog data. In the now for the connection, go to the LM35. LM35 has a three terminal, first and second terminal and third terminal. Now, what is the semantic of LM35? Let me show you. LM35. Okay, the temperature sensor. Okay. Huh. In see here in the LM35, pin number one is for the VCC voltage, pin number two for the output of the data, and pin number three is it will go to the ground. Okay. So again, we have to do the connection at pin number one to the VCC voltage. For VCC voltage, we require the DC voltage. So go to the generator mode, and generator mode, after going to the generator mode, go select the DC. Okay, DC input and connect to the terminal 1. Why I am connecting the terminal 1? Because see here, the terminal 1 it is connected to the terminal 1 is connected to the VCC. The VCC range for the LM35 is from 3.5 to the 5.5 voltage. Okay. So I'm going to the generator mode. Generator mode, I'm selecting the DC mode and I'm connected to the pin number one. This is our VCC. Okay. After this, the VCC power is not activated. You have to select the range. So two times select, right click. See here the voltage is zero. So you have to change the manually accordingly you. So I require the 3.5 voltage. Okay. So to run this IC, so change it to the 3.5 voltage and select to the OK. Okay. So always remember whenever you connect that signed DC to the your component, you have to change the voltage. By default, it will be the zero. So you can change also the manually. Otherwise, the selection of this and you can do this up and down. Okay. Then okay. Then the pin number two is your analog output. Means the data. Uh, the data is captured by the LM35 in the environment. It will be sent by the pin number three. Okay. Sorry, pin number two. And pin number three is basically the ground. So pin number two, we have to connect to the ADC. First, we have to connect the ground. Okay, ground is connected to pin number three. So again, go to the terminal modes. Terminal mode, select the ground and activate the ground, and it will connect to the pin number three. Okay, I connected the LM35 first, pin number one to the VCC voltage and pin number three to the ground. And now the pin number two, it will be used as an analog output. Okay, so the maximum range is 10 mega volt, millivolt, sorry, 10 millivolt. That will be divided by your degree Celsius. Basically, it will work in the temperature data. It will be sent in the range of your VCC power supply, and it will be changed into the degree Celsius. Okay. Now, from the pin number two, pin number pin number two, you have to connect the LM35 to the CH01. CH0. That is the first input of your ADC converter. Okay. After this, the LM35 connection is done. First, we have to connect the at the pin number one to the VCC and change the VCC, uh, clicking on the left right click 3.5 and pin number three to the voltage ground, and pin number two it will go to CH0, where CH0 is your the ADC converter. Okay. After this, again, see here, there is a three voltage. First one is a V reference, AGND, VDD, and DSD, GND. So V reference and VDD is basically your positive power supply. AGND and DGND is your ground power supply. So again, here you have to connect the power supply. So go to the generator mode, select your DC output. We require the two DC requirement at a pin number 15 and pin number 16. Okay. So one it's connected to the pin number 15 and another I will connect at the pin number 16. Again, I have changed the value. So select it two times. See here, it is default. By default is 0. So you have to change it to the 3.5 because on the simulator, it will be run on the 3.5 voltage. The range of the ADC converter and the analog analog digital converter, the range is 3.5. Okay. And pin number 14 and pin number 9, it will go to the ground. So select the ground from the terminal modes. The ground will be activated here. So both are the same. So I have to connect you to the ground with the same terminal. Okay. There is pin number 9. Okay. So pin number 14 for number 9 is go to the ground, and pin number 15 and 16 it will go to the V reference voltage. Okay. Where the V reference voltage is I have selected that the 3.5, and also the VDD it will be go to the 3.5. Then there is some connection. First one is the clock output, data input, and chip selector. So clock is basically the clock frequency that it will be the run your device that is connected to the uh, LM35. Okay, always remember whenever you connect your digital electronic circuit in the digital electronic circuit, we require a clock frequency. So the clock frequency it will be connected to the clock frequency of the Raspberry Pi. Basically, that is match the our speed of the processor and the data output by the IC. Okay, so same here, pin number 13 will be go to the clock frequency. Pin number data output D output it will go to the MISO. Okay, जहाँ पे means जो आपका pin number 12 है, pin number 12 is basically data output. Okay, data output means the data will be receive analog data from the terminal 2, that is terminal 2 of LM35, and it will convert to analog to the digital converter, and it send to the data to the Raspberry Pi. Okay, so that is your data output and data input. If data input means if we are required to take the data from the Raspberry Pi, so also we have to change, yeah, manipulate the data via the Raspberry Pi into our LM35. Okay, so we can do from the data input field. Now the chip selector is basically the selector which the time here, which the time period the data output or data input will be go to the IC. Yeah, it will be take the input of from the other sources. Okay, now again we require the default. Okay, so go to the default mode in the terminal modes, and we require the four defaults. So I will activate the four defaults. First default, second default, third default, and fourth default. Okay, and rotate it. Rotate it clockwise. And always remember, there is some space between the defaults. Okay, I have let me always remember there is some space between the default. See here, the defaults. Okay, let me do that first. Thing is, let me delete these objects. Again, I will be activate the four default and the sum is case. Rotate clockwise. Rotate clockwise. Okay. Now we have to again connect the pin number 13, pin number 12, pin number 10, sorry, pin number 11. Okay. Now the pin number 13 it will be go to the clock frequency of the Raspberry Pi. and to rename it clock frequency CLK, clock frequency CLK. Okay, clock frequency it will be activated here, and the pin number 12 it will go to the MISO. So MISO right here, MISO. Okay, and pin number 11 it will be go to the MOSI. FOSI. Okay, and pin number 10 it will go to the CS and chip selector of CS. Okay, the connection of the LM35 and ADC converter is done. Now we have go to the our program. Now go to the source code, and I have already written the code, so I am copy pasting Control C. So SPI here we are not connected any the GPIO pins. So SBR div is basically your serial peripheral connection. It will be activated by the SPI div, and the same how do we convert it to the LM35 and the ADC, it will convert to your temperature to the your degree Celsius. So I'm copy pasting that, and I will explain during our the practical session of all code. Then now run the program. Okay. After doing this, go to the debug mode and activate the simulation. Okay. And change the temperature. The simulation log it will be show here on your source code side. Okay. See 28-degree temperature and in now. So it is a simulator, so it will be take us some time to get that accurate data. Okay, because the CPU loading is 59 and 50%. So I am changing the temperature around see the temperature it changes accordingly. Okay, 21 and 20, 20, 19, okay, 18, 17, 16. The temperature is also changes. Okay, 16, 17, 18, 19, 20. Because it is simulator, so we have to change manually our temperature. So it will be show you the temperature. The maximum range of the temperature is up to the sensor is go to their maximum 33, 37. So it's 39, 44. So it will be take us some time to match the data which are we are changing the manual. Okay, login, stop it, check time and complication. So if this error will be done, so what do you have to do? Stop the simulator, again run the program. Okay, 57, 57. Okay, so it will take us some time to accurate the data, the maximum range of the temperature. So you can change the connection is done. Okay, and you how to activate the simulation now? Go to the debug mode and click on the simulation log. So simulation log is activated on your source code. Okay, source code also, and then it will be normally back to your simulation log on the semantic connection. Okay, so thank you. That's for your practical number 5th of the temperature sensor, and the source code it will be not visible during our simulation is running because so it stopped the code and the simulation of the code is visible. Okay, I will explain the code during our practical session. Okay, so thank you for